All right, welcome back. So this time we're going to go over transformer architecture and Gen AI. But before we get started, hit the like button, subscribe, and share to anyone you know taking the AWS Machine Learning Associate exam. So Gen AI models like ChatGPT and Claude are powered by the transformer architecture introduced in the 2017 paper, Attention is All You Need. Right. While AWS doesn't host proprietary OpenAI models, understanding transformers is essential for working with AWS services like SageMaker JumpStart, Bedrock, and Trainium. This foundation enables effective deployment of custom and foundational models. So, why transformers replaced RNNs? Recurrent neural networks, RNNs, process tokens sequentially, creating bottlenecks where long sequences lose earlier context. Each word must wait for the previous word to finish processing before it can begin. This sequential constraint prevents parallelization and causes information loss in longer texts. Transformers eliminate these limitations by processing all tokens simultaneously. Every word can attend to every word in the sentence, capturing long-range dependencies without sequential bottlenecks. This parallelization dramatically accelerates the training and improves context retention. So, let's see. All right, self-attention. Self-attention is the breakthrough enabling transformers to understand context. The process begins with input embedding. Each token, like a novel, becomes a high-dimensional vector. Positional encoding vectors are added because transformers process all tokens simultaneously and need position information. Each token passes through three learned matrices: query, key, and value. The system computes dot products between each token's query and every other token's key, generating attention scores. Softmax normalization converts these scores to probabilities. These probabilities weight the value vectors, and their weighted sum becomes the token's new context-aware representation. Consider novel in two sentences. I read a good novel. Makes novel attend strongly to read, indicating a book. That is a novel idea. Makes novel attend to idea, indicating newness. The same word gains different meanings through different attention patterns. Multi-head attention. Rather than computing single attention output, the transformer split vectors into multiple heads. These are smaller segments processed independently. Each head focuses on different relationships simultaneously, capturing syntax in some heads and semantics in others. Concatenating these diverse perspectives creates richer representations than single attention mechanisms could achieve. So, transformers in AWS. SageMaker enables training custom transformer models for NLP, text generation, and summarization. JumpStart provides pre-trained Hugging Face models like BERT and GPT-2 for quick experimentation. Bedrock offers fully managed access to foundation models from Anthropic like Claude or Meta like Llama 2, and Mistral for chatbots and document summarization. Trainium accelerates custom LLM training at scale. Inferentia provides cost-free inference for large-scale deployments. So, the cost structure. SageMaker Studio charges pay-per-use for compute and storage based on instance types. JumpStart offers free inference for some models, though training occurs EC2 or GPU costs. Bedrock bills pay-as-you-go per input and output token, varying by the provider. Trainium and Inferentia deliver low cost per throughput than general-purpose GPUs for training and inference, respectively. For experimentation and prototyping, use JumpStart or Bedrock. For large-scale, cost-efficient training, consider Trainium with custom training jobs. So you would use transformers in SageMaker JumpStart with a notebook, with your S3, and then you'd be able to configure that model, deploy some hyperparameters, and be able to test it and observe through SageMaker monitoring or CloudWatch logs. We're not going to do that because it takes a long time to deploy. So for the exam, remember a couple of things. When questions ask about processing sequential text efficiently, understanding context in large language models, or choosing AWS services for generative AI applications, understanding transformer architecture and its AWS implementations will guide you to the correct answer. So that's all we have for today. Before you go, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. Thank you, and have a good day.